Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, we're going to continue reviewing. What we're going to review is the chain rule today. Yeah, we're going to review the chain rule. So, take a look at this. See all this stuff right here? That's what we're going to copy down. So the chain rule is our weapon for deriving composite functions, or functions other than just plain x within other functions. Here are some examples of the types of functions the chain rule will allow us to differentiate. So the first thing you need to do is identify which ones need chain rule, which ones don't. And so in this case, this one's do not, and this one is need the chain rule. So write this down in your notes, pause it, and then start thinking about why we need to use the chain rule for these, because it looks like a function inside a function, and these ones don't because it's just a function in and of itself. Okay, so what is the chain rule? Well, here you go. Let's keep going. Let's scroll it. Sorry, scroll too much. So it's the derivative of the outside, keep the inside, times derivative of the outside. Sorry, inside. So derivative of the outside, keep the inside, times derivative of the inside. So it's all written right here. So pause the video and write this down also. The toughest part at first is identifying the inside and the outside function. So let's go do that. So I have a couple examples right here. So let's keep cruising. See A, B, C, and D. I want you to copy these down, pause the video. And also see if you can find the derivative of these. If you think you're a chain rule master, go ahead and do it. All right, let's do it. So the first one, f of x equals cosine of 5x squared. So this is the outside, the cosine. And then inside you have a different function that you can find the derivative of. So this is the inside. So f prime of x, always make sure you have the correct notation. So derivative of the outside, derivative of cosine is negative sine. Keep the inside times derivative of the outside, inside, which is 2 times 5, which is 10x. So if you want to clean that up a little bit, it'd be negative 1 times this, so it's negative 10x sine of 5x squared. Bam, and that is your derivative. Cool, got it. Let's try this one. F of x equals sine squared x. All right, so this is the same as sine x all squared. So this looks like x squared. So this is going to be f prime of x, here's the derivative, so it's 2, keep the inside to the first, so that'd be 2x squared, if this was said x squared, times derivative of the inside, derivative of sine is cosine. Cool. So the derivative is 2 sine x cosine x. Bam. All right, next one. G of x equals this. So I'm going to rewrite this as 3x plus 1 to the 1/2 power. So the outside is just radical x. So this is going to be a half times this, so derivative of the outside, so it's g prime of x, is 1/2, keep the inside, and then subtract 1 from the exponent, that's going to be negative 1/2, times derivative of the inside, derivative of this is, 3. Cool. So g prime of x equals, well, 3 is the numerator, so it's 3 over 1/2, so the 2 goes here, that's 1/2, and then negative exponent means the radical goes in the denominator. Bam. You go 3 for 3 so far? Let's see. Oh yeah. Let's try the next one. F of x equals 1 over 5x plus 1. So this looks kind of weird, but it actually is, if you rewrite it, pretty straightforward as far as a chain rule composite function. So 5x plus 1 right here to the negative 1. So the outside is negative 1 times this. So the derivative is negative 1 on the outside, 5x plus 1, keep the inside, minus 1 from your exponent, so it's minus 2. Times derivative of the inside, which is 5. Cool. So the derivative is 5, because 5 over 1, this is numerator, times negative 1, which is negative 5, over, when you have negative 2, that means that the term goes to the denominator, so it's negative 5 over 5x plus 1 squared. Cool. All right. Now let's try some 2 chains. Right here. So these are the ones that are a little bit further down. So it has like an onion right there where you have to keep peeling it. But we got two chains. So let's check it out right here. So write these down. See if you can knock these out if you got it so far. This is two chains. Ooh. Ooh. All right, let's see if we got it. Let's try it. So first one, right here. So I'm going to rewrite this. F of x equals sine of 4x plus 1 to the 1/2 all to the third power. So that's going to help me do everything. So when I turn the radical into 1/2 power, and then this sine to the third means the whole thing is to the third power. So it's this times this times this 3 times. So now this is in a good position to find the derivative. So it's derivative of the outside, which is 3. Keep the inside, which is all this fun stuff, squared. So this is like x to the third, so it'd be 3x squared to 3x squared, which is your derivative, times derivative of the inside. So the derivative of sine is cosine. Keep the inside. Times derivative of the inside, so that's 4x plus 1 to the 1/2. So that's 1/2 4x plus 1 to the negative 1/2. Times derivative of the inside times 4. Damn, that's a lot. That's all the whole thing. So you can simplify that if you want, but it's going to look like this. 3 sine squared of radical 4x plus 1 cosine radical 4x plus 1. Oh, multiply this by 4, my bad. So 3 times 4 is 12 out here. And then this is a denominator, half. So 12 divided by 2, I guess, would be 6. And this would be radical 4x plus 1 in the denominator. Yeah, cool. Let's do one more. Here you go. So g of x equals 3 over all of this. So I'm going to rewrite this as 3 times, important for use, tangent 4x squared plus 1 all to the negative 1/2 power. So this is on the denominator, and move it up and make it negative. All right, cool. So first thing, this is like 3x to the negative 1/2. So I'm going to do the power rule here. So g prime of x equals negative 1/2 times 3, which is negative 3 over 2. Keep the inside. Then subtract 1 from my exponent, so it's negative 3 over 2. Cool. Times derivative of the inside. The derivative of tangent is, yeah, secant squared. Keep the inside. Bam. Times derivative of the inside, which is 8x. Yeah. All right, nice job. So now let's simplify this in case we need to on the AP exam. So negative 3 times 8, there, negative 3 times 8, which is negative 24, divided by 2, which is negative 12x. This is going to be numerator since it's to the first power. So secant squared 4x squared plus 1. This is a negative exponent, so this goes to the denominator. So it is the square root of, this is the power, the tangent of 4x squared plus 1 to the third power. There you go. Sorry, now you see it. Cool. All right, one more. We're almost done. Nice job. Then you get to practice on your own. All right, so now let's look at something from a chart. So what if we have a chart and we have to do chain rule? No problemo. So let's scroll it down a little bit. Scroll it down. Oop, that's okay. So my computer is a little bit fussy right now. That's okay. What I want you to do is I want you to do all of the multiple choice right below. Answers will be online. Good work, everybody. Take your time and make sure you get them all right. Good work, everybody. Laters.